Hello, I'm going to go through a short presentation that deals with lab number 6, working with sequencers and arrays. And the presentation is not exactly the same as the lab that you'll be doing, but it's an example that probably will be helpful. So on the screen, I'm showing you a few different parts. On the left-hand side is the HMI, and the right-hand side is the program up in the top half, and the quick watch window down at the bottom. The quick watch window is showing you the value going out to a variable called lights, and I've broken it down into binary so you can see the individual bits. So this, for example, represents lights dot 0, the walking person, lights dot 1, dot 2, dot 3, 4, or sorry, 5, 6, and 7. And you can see that lights 4 is not used, so we're not using that bit for anything. And that's why the mask up here is set to 0, but we'll talk about that later. So let's just see a demo of how this is going to operate. So right now, this program is going through a loop, okay, and this is a sequencer. So what the sequencer will do is go through a step, and it'll start off at position 1, then go to 2, 3, 4, 5, 6, and 7, and then go back to 1. So it's kind of a loop, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. And I have programmed into an array which lights should be turned on and which lights should be turned off as we go through that loop. And this loop is being controlled by the walk push button. You can see that in the program. You can see this in the HMI. So let's just see what happens every time I press that button. Okay, so I'm currently on step number 1. And step number 1, you see it here in position number 1. It appears down here in my sequencer position. And it went to my array and sent out this pattern to the lights. And this pattern turns on the green north-south. If I click the button again, the pattern changed and it's turning on lights 2, which is the yellow north-south, and then the red north-south, the green east-west, yellow east-west, red east-west. So it's cycling through that, and then I'm at position number 6, and then 7 turns on the green of the north-south and the red of the east-west, and also the walk light, okay, which is bit 0. So here you can see in my variable list of the main program, I have the variable lights, and it has that little right pointing arrow, which means that you can open that up to see the individual bits, and you can see which bits I've connected to. And each of these bits are Boolean. But the array is actually going to write to a double integer, which the whole variable lights is. It's a double integer. Now, the next thing I want to look at is the array. And I know that this is an array because if I look over to the right, it says double integer. So it's an array of double integers. The array has to be of the same type. And there are 8 elements in the array. So it's broken down into 8 parts. That's why the number 8 is here. If I want to see the elements of the array, I just click on this pointing arrow. It opens up the elements of the array, and you can see it's element 0, 1, 2, 3, 4, 5, 6, 7. The array always starts at element 0 and goes to a maximum value. Now right now I'm in edit tags, but I want to switch to monitor tags, which is here. So going back to looking at monitor tags, and I want to see it for array 1. I should be able to click on this and open it up, and there we go. So you can see all of the elements of my array. The only problem right now is that the information is being displayed in decimal. Not a great way to see bits of information. So hexadecimal is better, but the best is in binary. So I'm going to switch to binary. You have to go up top here to widen this window. So I go up here, and now I can see all of the bits of the elements of the array. Okay, these are called elements. The whole thing combined together is the array. And each of these elements will be sent to this traffic light pattern, or the lights, one step at a time using the sequencer. It will output this pattern, then the one at number 1, 2, 3, 4, 5, 6, 7, and it repeats back at number 1. The first element of the array element 0, is kind of special. And to have that go out to the lights, two things have to happen. I have to be at position 0, and the input to the sequencer has to be a true. So those two things have to happen simultaneously. So let's look at this pattern. It's in binary. This is the least significant bit, then bit 1, bit 2, 3, 4, 5, 6, and 7. That's matching up with bits 7, 6, 5, 3, 2, and 1 of the traffic light pattern. And bit 0 is the pedestrian light. So you can see in this pattern, the only time I have bit 0 is turned on is in sequencer array element 7. Here I would have bit 1 turned on. Okay, that's bit number 1. And bit number 1 is the green traffic light. And here I have bit number 2 turned on. Bit 2 is the yellow of the north-south, and so on. Get familiar with the bit position. The one on the right is bit 0. All the way to the left of these 8 bits, that's called bit 7. So 0, 1, 2, 3, and then 4, 5, 6, and 7. So those are all the bits of the array. That's the value that will be sent out to the array. Okay, so now let's look at something different. Okay, the next thing I'm looking at is the sequencer control structure. So it's going to be called control. It's not a double integer, it's not a Boolean, it's a different type of data. It's called control. And within that control, you can see that it opens up. And control 1 will have things like length, position, enable, and done. To us, these are the most important bits right now. So length, len, position, enable, which is the input, and the done bit. And the done bit will go true when we are at element 7. And you can see right now we are at element 7. And let's look at what happens to position and length. Well, position is fixed. Okay, it's 7. We've programmed that into the sequencer. And when I press this button, oops, I lost that window temporarily. So when I press this button, you can see the sequencer goes to position 2, 3, 4, 5, 6, 7, and this is where the done bit goes true. And every time I press the push button, look at the enable signal. When it's pressed, it's true. When it's released, it's false. And it triggers the sequencer to move to the next element when it goes from false to true. So we're at 1 right now, and I press it, goes to 2. When I press it, goes to 3. So it's happening on the positive transition from a low level to a high level. Okay. Now, the other thing that we're going to have in this program is something called a time delay. And it's a time delay where the information is stored in a sequencer. So let's find that. We'll open Edit Tags, and there should be another array. That was the first one. And you can tell that it's an array because it has a number after the double integer text. So the delay array is here. And we're going to go to Monitor Tags so we can see the value of the array. And I think we have to open it up again. Just click on this little triangle. It can be kind of tricky, but there it is. Now, here we're looking at the data in decimal. Okay, and we can move this window over so it lines up better with that table. We're looking at it in decimal. There are 10 elements in the array, but we're programming a different amount of delay time for each time the traffic light changes the element that's being displayed. So at element 1, we had 1300 milliseconds, or 1.3, 1.4, 1.5, and so on and so on. Now, if we go back to the program, okay, the program doesn't have any delays right now. We'll look at that in a second example. But for now, every time I press this button, it's moving to the next element. Okay. And as it cycles through those elements, it's changing what's happening on the traffic light pattern. Next, we're going to look at a different example. Hello, in the second part of the demonstration, I've changed the program. So now I have a timer, an on timer, and I have a reset of that timer. So what's happening here is my timer will run continuously. It's a nonstop timer. And every second, it will reset that timer. So when the timer is done, it'll reset it, go back to 0, and count to 1,000 milliseconds. So it's a 1-second timer. And the other thing that it's doing, it's being applied to the input of the sequencer. And you can see it right here. That every time the timer is done, it causes this to go from a false to a true. And it will take the value that's stored in the sequencer array, which is my pattern for the traffic lights. It'll send that out through this mask. So it'll only modify the bits indicated in the mask, which are 0 to 3 and not 4, but 5 to 7. So 0 to 3 and 5 to 7. That will be sent out to the destination, which happens to be lights, which is my traffic light. And it's a double integer, but it's sending those bits of information to each of the bits of the traffic light. And my length is 7, so it'll cycle through 7 elements of the array. It'll go 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And you'll notice that when it does get to 7, the done bit goes true during that 1 second worth of time. And after that 1 second, it causes this to be done. Timer starts over again. And you can see that information being updated on the HMI and at the sequencer position. Okay. The pedestrian light here, what I've done for that is I put 2 black boxes on top of a hand that's saying stop and a hand that's saying go. And I just make them either visible or invisible. We'll look at that a little bit later. So that's kind of the second part of this demonstration, of which there are 4 parts. All right, so we'll go to the next demonstration part. All right, now we're into the third part of the demonstration where I've loaded a new program, and you can see it up here. Let's just, this time it's going to use a timer like you see up here, and it's going to have a second sequencer. And that second sequencer is in sync with the data sequencer. So you can see here that I have an array called delay array, which represents a certain amount of time delay. And this array is my data array, the one that we used before. And notice that I'm using the same length, okay, and the position is moving along at the same step, and that's because I'm using the same control structure. So the sequence control 1 is the same in both of these sequencers. What's different is the array that we're using in each one and the destination. Okay, it's important to see the difference between the two. So the destination for this one is the data from the array going out to the lights. But over here, the difference is that we're taking the delay array time, which was, I think I showed you it in a previous example, which is in certain amount of milliseconds, okay? 1,200 or 1,400 or 2,000. We're taking that information and we're sending it to the preset of this on timer, the timer delay. And you can see it's going to timer delay.preset. So now that we've sent out that information, the 2 sequencers are moving in step, and it's modifying the accumulator, or sorry, the preset, which is changing the value of the accumulator as we go through the sequence. So sometimes we want a certain bit pattern to stay there longer than other times, and that's what's happening in this example. It's going 1,400, 1,500, 1,600. You can see that up here. And it's changing in sequence with this step. Okay, and you can see that down here as we change. It's a little bit quick, but these numbers are in hexadecimal. These numbers are in binary. So it's 83. That tells me a couple of bits are on. Bit 3, that was 3, and then another bit and another bit, and so on as it's going through the sequence. And it's automatically incrementing to the next sequence based on when this timer is done. And the timer is done at different intervals because of the delay time that we're using. Okay, so that's the end of part 3. I'll load a different program. Okay, this is the fourth part of the demonstration, and I've modified the program. I've added some more instructions, but basically we still have the timer delay. Okay, we still have that. We still have the sequencer for the time delay, which is this one. It's hard to see in this example here. Let's see if I zoom in. Okay, you can see that it's pretty much the same. Maybe we can even look at it this level. That I have just 3 lines of code, so not a lot of lines of code. And in the first line, it's just the on timer. And in the last line, rung 2, it's just saying that when that timer is done, move to the next sequence in the timer or sequencer in the array. And it does that by just resetting that timer. So let's see what's happening here. So I had those 7 elements in the array, plus there's actually an 8th one at element 0. And I'm trying to output that information to the lights. So there's 2 sequencers, one that's outputting to the lights and one that's updating the timer in the the preset of that timer. So this one is modifying the timer. This one is modifying the array data. And I have an OR. I've got 2 different types of OR situations. I've got this rung here, which is an OR, and this rung here, which is multiple ORs. So what this one is doing is that whenever the first scan occurs, it will do this line and it makes that input true to the sequencer, and it also moves 0 to the sequencer position. And what's special about that particular event is it causes the first element of the array, element 0, to put information to my lights pattern and to my delay. So let's just see what happens. So that can happen on the first scan of the program, or it can happen when I press lamp test. So I'm going to press lamp test. Okay, and see what happens here. The lamp test is true for both parts of this OR. And what it's doing is it's moving 0 into the sequencer position. And you can see that right now. The sequencer position is 0, and the input to the 2 sequencers is true. It's going through that lamp test. So that's the unique condition that will cause the sequencer to go to the first element, and we're using that to set up a test for all of the lights in my traffic pattern. When I release that lamp test, it goes back to performing the same step sequence. Or I can manually advance it using this push button, okay, because I have an OR here. It's advancing the sequencer based on time, or it's advancing the sequencer based on the walk push button, either one of those. Okay, so that's kind of gives you some idea of how to do this. Obviously, it's not the same as the program that you will be using, but there are a lot of similarities. The thing that you will have to change quite a bit is the information that's going out to the data array. Okay, this pattern here. And let me just show you that. I can probably do it while I'm online. I'm going to set it up so maybe 2 reds come on at the same time. So in this pattern here, I'm going to change this to a 1. Okay, and you're going to see at some time at element number 6. I probably have to hit enter there. And element number 6, let's just try that loop again. That's 5 and 6. I probably have to download that pattern, which I didn't do. So that's a bit of a demonstration. You'll have to download it to see it happen, but that's where I'd modify the time, or sorry, the data. And the delay array, let's see if we can find that. And it's going to be an array, so we're looking for a double integer that has a number after it. And you can see that it's right here. So maybe what I'm going to do is change a couple of numbers. Okay, in this final part of the fourth part, I want to show you the change that I made. So my delay array, I modified 2 of the elements. So element 1, I changed it to 4,000 or 4 seconds. And I modified element 3, and I also changed the sequencer array in element 1. So what I've done here is I've turned on the green light for the northwest and the green light for the other side. So both green lights will be on simultaneously. And I did think same thing in element 3. Both red lights are turned on. So we want to see that those 2 points have a 4-second delay. So I'm going to download the program. All right, in this part you can see that there is a new sequence now. So here are my 2 arrays, my delay array. Here's my sequencer array where my data is stored. And you can see that in element number 1, okay, when it's going to position number 1, the 2 green lights are turned on, and here are the 2 red lights at element 3. And up here you can see there was a change as well to element 3 and element, what was it, element 3 and element 1. And you can see over in the program that when we're on that step, so we're on step 4, 5, 6, and then that's where the 2 lights are on. But this is element 1. So element 1 has the longer delay and the 2 green lights on. And then element 3 has the longer delay and the 2 red lights on. So you can see I can change which pattern I want to have appear on the traffic light pattern. And that's what you're going to have to do in lab 6, is get the correct time delay based on the information in the lab and get the correct pattern. So I hope this helps. Hello, in part 5 of the demonstration, I want to show you a little bit about the HMI. It might be slightly different than the one you'll be using, but let's have a look at it anyhow. So here's my HMI. I stopped it from running just to show you a little bit about the HMI. So each of these represents a colored light. If I want to look at the properties, I click on it and then right click, go to properties. It shows me a little bit of the properties, but what we want to look at is all of these lights use an animation called color animation. So this tells me that that light is connected to bit 3. It's gray when it's false and it's red when it's true. And if we go to the next one, we go to the animation properties, color, and I think I can actually move this over and see each one at a time. This one goes yellow, it's connected to bit 2. This one goes green, it's connected to 1. This one is on 5, it goes green and yellow and red. And then I think there are a couple others here, but let's look at them individually. So I checked all the lights. Now I want to click on testing, and this is not a color change. So I'm going to close this and right click on it and go to properties. This one is actually a momentary push button, and it's connected to lamp test. Okay. The next one is visibility, and the properties there are under animation, visibility, and you can see that this is lights.0, and it's visible when it's true. So it blocks that off. Okay, it's blocking that particular square. I can go to this one, slightly different, animation, visibility, and this one is invisible when that bit is true. And if I move this over, I think that's the hand. Okay, so when you want to display the hand, you have to make that bit invisible. Let's go to the next bit. So all my time delays, if I go to connections, I can see that's connected to my timer delay.accumulator. And this one, I believe, is the timer delay.preset. Yes. And then this is my sequencer position. I can look at that properties and go to connections, sequence control 1.position. What else do I have here? This countdown timer, properties, go to connections, and it's the walk countdown. The other one that's important is this push button here. You gotta make sure you're selecting the right one. And we go to its properties, and it's called a momentary push button. Its connection is to walk push button, normally open. And then finally, this little light, hard to get it to click on, but there it is. Go to properties, and and I think it's colors or visibility. So we'll go to animation, it's color. So it changes to red when it's true and brown when it's false. Okay, just to make it look like a bright light or a dim light. I think those are all those points.